Welcome to Student to Student, a series of animated calculus videos that will help you prepare for the AP exam. These videos were made by students for students.
This is 7.3 and 7.4, sketching slope fields and reasoning using slope fields. So first we're just going to start off with a very rough example, if you will. It's just the basic concept of sketching and plotting a slope field. So we're going to start with the function f of x equals x squared. As you can see to the left, this is the graph of x squared. And then what we're going to do is we're going to take the derivative of x squared, so 2x, and then we're just going to plug in a bunch of different x values into the derivative, and this will give us the slopes at any point. So f prime of -2 equals -4, and so on. And because this function has symmetry at f of -1 equals -2, all of the slopes at x equals -1 are going to be -2. So moving all the way up here, and moving below it, they are all going to be -2. So then once you have the slopes plotted, then for each point, then they just become a bunch of dashed lines like this. And then this is what the slope field would look like for dy dx equals 2x.
So reasoning using slope fields. Imagine you're given two equations, dy dx equals x squared versus dy dx equals -x squared. How are you supposed to figure that out given just a slope field? Well, look at where the points, or look at where the slopes differ, right? So on the left side, all the slopes are negative, but on the right side, they're all positive, meaning that this is roughly like the shape of a parabola, like a positive parabola. So it couldn't be -x squared. Another important thing to look out for is for zeros, where they would show up as horizontal lines. So there's a horizontal line completely down the y-axis.
This is number 4 from the 2005 BC FRQ. With the differential equation dy dx equals 2x minus y, we have to sketch the slope field through the given points, then sketch the solution curve through the initial point 0, 1. First, we have to find and plot the slopes for each point given by plugging them into the differential equation. Next, we plot the initial point, 0, 1, and then we draw the curve through that point, following the flow of the slopes like dropping a feather into a wind current.
So, to start this off, we should label the point A, which will be at 0, 2, like the question stated. And then to sketch the solution curve, you just pretty much need to follow like the shape that the slopes are making. So this line follows the shape of all the slopes, roughly.
In this example, we have to start at the initial point, 1, 2, to find the limit as x approaches infinity of f of x. The slope field is given. First, we must plot the initial point. Then, we draw the curve following the flow of the slopes, like dropping a feather into a wind current. The slopes flatten out to 0 at x equals 1, so the limit as x approaches infinity approaches 1, which is answer D.
This is a 2015 FRQ, and it was question 4 for both AB and BC. And so the question starts off by saying, consider the differential equation dy dx equals 2x minus y. So for this question, we're really just going to focus on the last part, C. Let y equals f of x be the particular solution to the differential equation with the initial condition f of 2 equals 3. Then we're supposed to find if this point of f has a relative minimum, maximum, or neither. So starting off, we're going to use the point that was given, which was 2, 3, and we're going to plug this into the formula for dy dx. And when you plug those numbers in, you get 1. So here's a slope field for dy dx equals 2x minus 1. And I did want to note that for this FRQ, you wouldn't have graphed 2, 3 in part A, which was a sketching portion of the question. But I wanted to include it just to help you visualize the slopes at this point and visualize the process. So Next step, you have to understand that dy dx is a derivative. So a relative min or max is going to take place when the derivative or dy dx equals 0. And on a slope field, this would be when the lines or the slope is horizontal. So since 2, 3 does not equal 0, it has an actual slope, there's no change in sign, therefore there is neither a relative min or max. That students were awarded 2 points for this part of the question. You got 1 point if you plugged in the point 232 dy dx correctly, and then you got the other point if you stated if this was a relative min, max, or neither, and you justified why this was. So in order to get that second point, you had to say this was neither a relative min nor a max because, and then you would explain the reasoning. Overall, we hope that this helped you just study and review for the AP test. Good luck on the AP test. You got it. Just keep reviewing and you'll be good.